Okay, so we got this file from what we did last time. And we had two flavors of the write text file, right? So let's collapse this. So we have this write text file that takes a boolean, and we have another write text file that doesn't take anything, right? So we overloaded that method. We said we had two different versions of that. So in here we chose the one that has no parameters. So which one should it match to? Well, it should match to the one that has no parameters either, right? So that's called binding. So when you do binding, is when the computer matches the signatures. Now, when you go on computers, you're gonna learn something called, you're gonna take this class called data structures, hopefully. You're gonna learn about late bindings. And you're gonna learn about generics, or if you do it in C++, you're gonna learn about templates, which is the same. And basically the binding doesn't occur, it happens later. So anyways, so now you know about binding, you know about aggregation. We saw that. So what happens, let's close this file. Let me revisit an old one. Close project, there you go. So we did the die the other day, and we call this constructor, right? Constructor is simply it's called, and they also bind based on if you pass parameters, like we had the scanner. And we use the constructors to initialize variables, you know, to get it ready to be used, basically. We can have multiple versions of a constructor, right? We could have an overloaded constructor, like the scanner class does. However, as a constructor, I mean, we also have something called destructor. And destructors do you think we should have multiple types of destructors? Like you throw away something, you think there are multiple ways to throw away something? No, you just throw it away. So in the main class, so I have a die here, right? I'll use the die. How do I get rid of the die? So in the die here, right, it creates a version, calls the constructor, and it gives me an address to where it built it, right, in memory. So I could have two dies, right? I actually could have another die, your die, that is right now your die is simply a variable that has nothing assigned to it. But I could do this. Your die equal my die. Will your die work now? Yeah, there's only one die, right? It's just the two variables I pointed to the same thing. If I were to do this instead, then we'll have two dies, right? Because there were physically two different addresses in memory. So you can change where this variable is pointing to. So if I say your die equals my die, so let's put a breakpoint. Oh, it has already a breakpoint. So let's walk this through. So there's my die, right? I create it, and it's gonna set the address where it's going to. Oops, I click step into, and it creates the die. So the first one is gonna say is rand equal null. Yes, it's null. Then creates it. No, rand has a value. And that's the address where physically the RAM is located, right? So I roll it. Okay, go back to roll. You notice my stack keeps changing. So go back to where I was called before. And there's my die. My die has a value 2. That's ID 20. It's easier to say 20 than 36810. Right? And then your die creates a new die. Rand has a value. Skip it, then goes to roll, and notice here in your stack, keeping track where you are. Now your die has some different values. So ID 32. My die is 20, right? But then I say your die equals my die. So now your die is 20 and my die is 20. So what happened to die 32? Where is it? I don't have access to it anymore. There's no way for me to say whatever address to recapture the address, because I didn't hold it anywhere. I didn't put it in a variable to be held. So if you were doing C++ or C, you will, if you do this, you will no longer have access to that memory address, but it's still there. So when you have memory addresses that you cannot access anymore, you allocated memory that you cannot access anymore, meaning you lost its reference or their reference, as a name. You know what that name is? It's memory leaks. So a memory leak is simply what we just did. However, we don't have a memory leak because Java takes care of it. Java will keep a track of things that that are not referred, don't have a reference anymore. So that die that had the ID 32 is simply reclaimed to the operating system. So it gets destroyed. But we don't write any code for destroying anything, right? Well, you can. Like before this class die, if you want to do something else, let's say, somebody's logging off from the computer, want to stamp the time they log off before they close. Then I can use a destructor. The destructor, there's only one version of it. Go finalize. I'm sorry. It's a finalize method. So actually, the finalize method exists in all the classes. So I could do here my die dot, and then finalize is there, right? What happens if I do keyboard dot finalize? I don't see it. I don't see that method there. But it's there because the keyword gets destroyed, right? So that's what's called a destructor. And this brings me to something else. So here we created this die. We had the value 32, ID 32, I'm sorry. And then we lost the reference. That ID 32, the other die, is still in memory. And it's gonna be there for a while. When does the memory get released back to the operating system? So what happens is, you have your RAM and you start using the RAM here, start using RAM, and then all of a sudden you said, oh, I'm done with this RAM, and I'm gonna flag it as reusable, but I keep adding every new stuff I do. I keep adding here, now I got more here, whatever programs you're doing, and then all of a sudden you say, I don't need this RAM anymore. I flag it reusable, but you keep adding stuff here on top. That's, you're stacking stuff, but now your RAM has holes in it. That's called, I mean, you fragmented your RAM, right? So at some point, when the program is not busy, I want to push this one down. Oops. I want to push this down, and I want to push this down, and now I can add on top here. So I defragmented my RAM. You don't control when the RAM is defragmented.
Java does that for you. Java defragments your RAM for you.
Yes, actually, your operating system does. Java, all it can do is say, can you please, when you get a chance, next thing you do, can you defrag my RAM? If the operating system is busy doing other stuff, it won't. But if it's idle, like if you run your task manager here, your CPU is 18%, 16, whatever. If it gets down to like 1%, I'm not that busy right now. Sure, I can do it, right? So it runs a program to do that. This program is called garbage collection. And this garbage collection is basically the defrag program. You can only request to be run at certain points. Another way to eliminate or get rid of variable, what happens if I do this? It's perfectly legal, right? I just remove the reference and put it nowhere. So that basically flags that same address as reusable. So we have this system dot out, that print line that does stuff, right? There's other things in this system. So there's one called exit. So if I run the program, it ran already. See? Because I said system.exit. So that's basically a library that talks to the operating system. Now, there's this GC, that's a static. That's garbage collector. That will basically request to the operating system, hey, please defrag my RAM. If you don't, but you don't write it anywhere. Sometimes I've used that in programs that are memory hogs. I'm trying to free stuff. So, if you don't call it, the operating system has a timer, I don't know, 2 minutes, whatever the operating system thinks is appropriate. Although the operating system doesn't think, whoever wrote the operating system thought it was appropriate. And it runs it. Questions? All right, let's take 10 minutes. I need my coffee.